So we're going to call state 0 the state where there are no cars in the car wash. And let's assume it's a little one bay car wash where you have somebody comes in and does the wash and somebody else does the wax. And different cars take a little bit different amounts of time. So let's call the rate of cars arriving per hour lambda, and the rate of cars that can get washed per hour mu1, and the rate of cars that can get waxed per hour mu2. And we're going to call the system state 0 for when there are no cars there, 1 to where a car is getting washed, 2 is to where it's getting waxed. The rates have to be consistent. You cannot mix hours and minutes here. As long as everything is consistent with the rate, it will work. But make sure they're consistent. Okay, so here's your transition diagram. Real simple. So you're going to have some rate. This is the transition rate diagram. Lambda of arrival. So car drives into the car wash. So let's say we're looking down at the car wash. Here's your lane. And your car shows up. Great drawing, right? Car shows up at the car wash and he goes in. So, and here's your exit. So one car in the car wash, this is 0, the guy shows up. State 1, state 2 happen in here. This is the wax. So wax, there's a rate of mu1 cars per hour getting waxed, and mu2 per hour, I'm sorry, this is getting washed, and mu2 per hour getting waxed. At which point the car exits, and we're going to assume no queuing, that cars only come in when there's no line. So there's a real simple Markov chain right there. Now, let's make this a little more interesting. Let's talk about what happens when there are 2 bays. So let's say you have an entrance ramp here, and the cars come in, and then there are 2 bays in here. And then they exit and go on their merry way. And if a car comes in, they're going to go into an empty bay if there's an empty bay. So in this case, we're going to change our states a little bit. And we're going to say that cars are still arriving with rate lambda, and that it takes rate mu to clean them, and this time we're not going to worry about waxing. And so our state is going to be number of cars in the car wash. So a little bit different model here, okay? So we're still going to have similar looking state diagram. But when we put in our rates, now we're going to say, okay, they're arriving at rate lambda. So it can go from 0 to 1 and 1 to 2 with arrival rate lambda, since that's the number of cars in the car wash. And if you have one car getting washed, the rate of washing is going to be 1 car per hour. So going from, mu cars per hour. So going from 1 back to 0 is mu. That rate's going to be mu. We're never going to go straight from 2 to 0 because we're going to assume that both cars are never going to get finished at exactly the same time. So there's no chance of this happening. But the rate of transition from 2 back to 1 now is going to be 2 mu. Why? Because if you have 2 cars in here at any given time, they're coming out twice as fast, even if you're washing them at the same speed. So if you think about this and consider cars coming in and getting washed, if you were to sit here or look down at it and see the cars coming out, if you have a car in each bay getting washed, you're going to have twice as many cars coming out over any given time period on average than you are if you only have one bay going at a time. So next we're going to go over how to make the transition matrix. So it's called Q. So we're going to start off by putting the negative Q of i's on the diagonal. And the Q i's are just the total transition rates out of each state. So let's take state 1. So Q1 is going to be the total added up transition rate out of state I. It doesn't matter where it goes from state I, just the total. Okay. And then the other elements are going to be the transition rates from that state into the next state. So if this is 0, 1, and 2, this is going to be same as we did with the P matrix. This is going to be the transition rate from state 0 to state 1. This is going to be the transition rate from state 0 to state 2, and so on and so forth. And this will be Q12, Q21. Okay, so now if I want to fill this in, for example, in the car wash example, all right, the transition rate from state 0 to state 1 is lambda. So I could do this. From state 0 to state 2, well, that doesn't happen. So that's going to be 0. And then the rows have to sum to 0. So we're going to set minus Q naught to be the sum of the row except for the diagonal with a negative sign in front of it. So in this case, minus lambda. Now, the transition rate from 1 to 0, well, if we have one car in there, they're getting washed at rate mu. So that's going to be mu. From 1 to 2, well, that would be another arrival. So that's lambda. So Q1 has to be mu plus lambda. And here we're going to have minus Q1. So minus mu plus lambda, because the rows sum to 0. All right. Sum to 1 for a probability transition probability matrix. We sum to 0 in the transition rate matrix. Okay, 2 to 0 doesn't happen. 2 to 1, well, that's happening at rate 2 mu in this case. And so therefore, Q2 has to be, well, the sum of this. There you go. So minus 2 mu. Again, the row sums to 0.